It's a special pilot project that's being run actually for quite a long time now. We started with the first 2 vehicles on the road in 2007, and that's one of them. As you can see on that truck, there's an RTMS board, and when we started with the project, we decided that any operator that wanted to participate in this project would have to be RTMS certified to have a certain level of compliance and assurance that responsible fleet operations, because these are special vehicles, and I'll go into a bit of detail now. So it's about the approach to PBS, the PBS approach to vehicle design, the pilot project in South Africa, and some monitoring results. As I mentioned earlier about the benefits that we've observed from the RTMS project in terms of maintenance and drivers, the PBS approach focuses on vehicle design, and I'll explain that now. We're not talking about designing the chassis or the bin or whatever it might be. That's the trailer manufacturer's responsibility. This is more about getting the proportions right to get a more stable vehicle on the road. So this is a formal pilot project being run under the auspices of the National Department of Transport, and the idea is to look at the research that's been done in terms of PBS around the world, particularly Australia, Canada, and New Zealand, and to how we can improve heavy vehicle operations in South Africa with respect to reduced road wear, reduced vehicle trips on the road, improved safety performance, improved transport productivity, and reduced emissions. So there are all those potential benefits. Yesterday I was in a WebEx, I participated in a WebEx conference that was in Paris. I've been involved in an OECD project called High Capacity Vehicles, and there were about 30 of us participating. About half were in the conference room, and the other half were Skyping in from Australia, United States, South Africa, etc. And there are a number of countries now that are running pilot projects using PBS as a basis. In Europe, it's mainly about reducing congestion and emissions. Those are their 2 big objectives in terms of these objectives that we're looking at. Right, so another couple of video clips. Heavy vehicles are a lot less stable on the road than cars, okay? And what the main reason is because of the center of gravity height. So this is a clip, whoops, sorry. Hopefully these will all run. Truck going down the hill, going too fast, center of gravity causes the rollover, right? This one is also this one I got from Durban last year. So these are examples. This was down in Cape Town, Wingfield Interchange. Just watch the traffic coming towards you. And the last one is a very experienced driver, actually, probably. So the point is that the prescriptive regulations which we use in our Road Traffic Act to control vehicles on the road, and in this case heavy vehicles on the road, the research found that they don't really address the problem mainly of vehicle dynamics. The things that I've showed you now, you can have vehicles that comply with the Road Traffic Act. We call them prescriptive standards on the left. It defines what the vehicle looks like, and it's normally through dimensions and mass. Those are the 2 main things about controlling a vehicle, but they don't guarantee a stable vehicle on the road. A performance-based approach, and performance-based standards have been used in many industries, in the medical industry, road construction, the food industry. It's fairly new in heavy vehicles. it looks at how the vehicle performs on the road. It's a bit more complicated than a prescriptive approach, but it does allow longer and heavier vehicles on certain dedicated routes. So if you can imagine, the road infrastructure in our country goes from high standard roads to low standard roads, which would be residential streets. That's the very lowest standard. And yet our regulations for heavy vehicles are consistent. So a 22-meter, 56-ton truck can travel virtually on any part of the road network. So when a 56-ton, 22-meter truck goes into a residential area, it becomes very unsafe because the roads are not designed for that type of vehicle. With the PBS approach, you say, okay, we allow a longer vehicle, but it's only allowed on a portion of the network that can safely accommodate that vehicle. Because obviously when you're on the N3, the standard of that road is much higher than in a city, for example. So I'm going to skip that slide. It's just the timeline of the project, but we're a bit short of time. So we decided to base this project on the Australian performance-based standard. So rather than try and reinvent the wheel, different countries have developed requirements for a PBS approach. The Australians have adopted it into their legislation. They've done a lot of research. So we said for the pilot project in South Africa, that's what we're going to use. And in the meantime, we have done a bit of fine-tuning for South African conditions. What does it involve? The nitty-gritty of the PBS approach is that you model the combination using sophisticated computer software, and you put it through some maneuvers, and I'll show you a couple of examples. So there's a slow-speed turn, there's a high-speed lane change maneuver, there's a rollover test, there's a high-speed pulse steer, etc. And you model that very accurately on computer. Tire stiffness, suspension, load, everything. And when you put it through those maneuvers, you measure certain things, and those are what are called performance standards. And I'll show you a couple of examples. So I'll show you an example of low-speed swept path. That's very important when a truck goes around through an intersection. How much space does it take up? I'll show you an example of rearward amplification and high-speed transient off-tracking and rollover. Okay, so when a truck goes around a corner, depending on its length and its configuration, it takes up space going around the corner. So the trailing axles don't follow the steer axle, and that's called swept path. So that distance there is a performance standard. That's the swept path. And that is not directly related to the length of the vehicle. So a longer vehicle can have a lower swept path than a shorter vehicle, depending on the articulation points, the length of the drawbar, the wheelbase, etc. So this is a little clip from Australia. I'll just showing a legal vehicle, truck, tractor, semi-trailer, going around a corner. Now they're measuring swept path, okay? So you can see it does sweep a little bit. The next one is also a legal vehicle, 2 trailers. You can see the increase in swept path. This is a legal vehicle. It's 19 meters long. The next one is a 20-meter PBS vehicle. So it complies with the swept path performance standard, which we call low-speed off-tracking. It's got an extra articulation point, and you can see it performs more or less the same as the first vehicle. This is also a legal vehicle in Australia. It's 25 meters long, B-double, but it's got a very poor off-tracking performance because of the long wheelbase on the second trailer. And the last vehicle is it's a meter longer. It's 26 meters, but it's a PBS vehicle. And you can see it's got a much better swept path performance. So that little video clip illustrates the difference between a prescriptive approach and a performance-based approach. And that's just one of the standards. So now another standard, the high-speed lane change, you can see there it's a standard maneuver, Society of Automotive Engineers, and you measure the response of the trailer. So here, this one on the left is a baseline vehicle in timber, a rigid truck with a drawbar trailer. It's very common for transporting timber. And this baseline vehicle failed the performance standard. So it does this lane change maneuver. It's an aggressive lane change maneuver. It's not the sort of thing you would do very often. But the response of the trailer was such that it failed this test. So it doesn't pass. This was that photograph I showed you earlier. It's 27 meters long, and it does the same high-speed lane change, but it's been designed to pass the test. So you can see it's a lot more stable. And that's because of the suspension, wheel track, hitch position, length of drawbar. Those parameters you play around with to get the combination to comply with the performance standards. And then the rollover test that's now one of the big problems with trucks is rollover. Most of those video clips I showed you were a problem of rollover. In this case, you've got a 30-meter rig, which is the red one, and the baseline is the blue one. And you have a constant radius curve. You increase the speed of the truck until it rolls over. The truck or trailer rolls over. That lateral acceleration when it rolls over is called the static rollover threshold, and it's got to be at least 0.35 g, where g is gravity. So it's a mechanical engineering or an engineering thing, but you see now, you're speeding up the truck. Now you see that the baseline vehicle rolled over at 0.27 g, and the PBS vehicle rolls over at just over 0.35 g. So 0.35 g is the requirement. So these two vehicles going around a corner at speed, the baseline vehicle actually has got a much higher chance of rolling over. There's also performance standards in terms of infrastructure, pavements or roads and bridges. I won't go into detail, but this graph shows road damage per ton of payload. The blue diamonds are the baseline vehicles. These are all mining vehicles. And we find that especially trucks with single tires cause a lot more road wear or road damage per ton of payload. You can see some of those causing a lot more road damage. The red squares are all the PBS vehicles. So they're all designed so that their road wear characteristics, if you like, they're road friendly. They're consistently road friendly vehicles, as the same as the best of the baseline vehicles. And this is something that's quite difficult to comprehend, that a truck that's, say, 75 tons is actually causing less road damage per ton of payload than a 22-meter, 56-ton rig. But this came up in the webinar that I was participating in yesterday, that it's very clear, the research that's been done in a number of countries, that the high-capacity vehicles, as long as they've been designed in terms of their tire footprint, can do significantly less damage than the baseline vehicles or legal vehicles. I'm not going to go into this, but we also do bridge checks. So all the PBS vehicles that are running in the pilot project, we do some bridge checks looking at bending moment and shear force to make sure that they're not a risk to our bridge structure. But there's not time to go into that detail. Okay, the question was, should we run a pilot project in South Africa, PBS? And some people said, no, we've already got PBS. We've already got high-capacity vehicles in Africa, but obviously not very safe and probably causing a lot of road damage. This is the pilot project. Now I'm just going on to the monitoring results. At the moment, there are 282 PBS vehicles operating in South Africa. You can see the bulk of them are in the eastern provinces of Limpopo, Mpumalanga, and KwaZulu-Natal. The commodities, the most popular one now, common, is fuel. The fuel quotes, I'll show you a photo. And then we've got timber, mining. We've got coal separately. And then there's processed sugar and a few beers, very importantly. And quite soon it will be Coca-Cola. Up to now, we've done, that shows 136 million. That was some months ago. As of the end of December, the pilot project had covered just over 150 million kilometers. These 282 vehicles are doing about 3 million kilometers a month. So that's the kind of kilometers we're gathering. It's very important for the pilot project to get sufficient kilometers to compare the crash rates. We're very interested in crash rates and fatality rates. How safe are these vehicles actually in South Africa? You know, it's all very well to look at statistics from New Zealand or Australia. We want to know how these vehicles interact with South African drivers. So we developed a strategy through the Department of Transport. We got a letter from the Minister of Transport in 2007. It was Minister Khadebe. and got approval to run this pilot project. And we've developed a rules document. So any operator that wants to participate, that's the document that tells them step by step how you participate. We do route assessments. This is an interchange up near Polokwane for a ZZ2 PBS vehicle that's not operating yet, but we can look at specific interchanges or intersections to see that the vehicle can safely navigate them. And typically, if a province is not happy with a particular intersection, they can require an assessment like this to be done. This is an SA Breweries assessment from the brewery in Prospecton, Durban, and then one of the intersections that the DOT were not comfortable with, and that just demonstrates that the vehicle can safely pass through. In fact, normally the big constraint for an operator is the depots and the delivery points in terms of space. And the operators are required to submit monthly data in terms of route compliance, kilometers traveled, tons transported, and fuel, so that we can monitor the improvement of these vehicles. We're also looking at real-time monitoring, talking to telematics companies, so that if the vehicle goes off the route that it's been approved to operate on, or if it overspeeds, there will be immediate communication with the road authority. So if a PBS vehicle goes off, for example, this route, then it would generate an email that would go to the operator, but also to the road authority to ensure compliance, because route compliance obviously is very important, and speeding. Okay, so I just want to show you a couple of examples. The top one is a legal timber vehicle, 22 meters, 56 tons. These are some of the PBS vehicles in timber that have been operated. Interestingly enough, initially, the operators wanted to go for longer vehicles in terms of like 27 meters, get the bigger payload, but there were some constraints in terms of operating on forestry roads. So the trend has gone now more to 22, 23 meter vehicles. This was one of the original ones. And then this is a 22 meter rig used by Buhlabetu. So the axle loads are not exceeded. So on a tandem axle unit like you see there, you're limited to 18 tons. So these vehicles will be running at 18 tons per axle unit. The front steer axle is 15.4 tons, but they're not restricted to the 56 ton limit. So this vehicle will be running at about 65 tons. So you've got an increase in payload, then you've got the benefits of reduction in emissions, less trips, lower fuel consumption, etc. This is another one in KwaZulu-Natal. Barloworld side tipper. It's also 22 meters long, but you see it's got two tridems, so it's 24 plus 24, and that thing's running at about 75 or 72 tons. It's got a 50-ton payload as opposed to the normal 34, 35-ton payload. Big reduction in trips, big reduction in cost. This is a rearward amplification. So this road train on the left was run at Richards Bay Minerals in KwaZulu-Natal for about 10 years under permit, not a PBS vehicle, and they wanted to go up to a 4-trailer combination. Now this combination failed rearward amplification horribly. In fact, you can see it's a pretty unstable combination. And the KZN DOT said they would allow a bigger road train. The one on the right is 185 tons, 42 meters long. But it was being designed to pass the rearward amplification performance test. So you can see there's a big difference in terms of stability of the vehicle on the road. And remember, these vehicles have to pass all the standards. And it's a bit of a juggle. So, you know, sometimes you get it passes 3/4 of the standards, and then it fails 2 or 3 of them. And now you've got to start playing around with the different parameters so that it passes all the standards. And then you end up with a very stable, safe vehicle. As another example, a sugar bottom dumper. It's also not over length. This is the coal one in Mpumalanga. That's, I think there are about 30 of them running. And these can help to reduce cost of electricity. I don't think they'll help with the load shedding, but well, maybe they will, because you know the coal has got to get to the power stations, and in fact, Eskom is putting as much coal as they can on conveyor belt and then rail, and their third choice is road. But you know very well that there's not conveyor links and rail links between all the mines and the power stations. So this year, apparently, they have to put an extra 60 million tons of coal on the road, which cannot be carried by their conveyor because of the location of the mines, etc. So this is a big potential for increasing safety, reducing trips, reducing costs, and reducing road wear. I think this vehicle does about, I can't remember, I think it's about 40% less road wear per ton of payload than the baseline vehicle. And there's a fuel quad that's been run. This one's been run mainly on the, I think, just Durban-Joburg. You should see them. They'll have an abnormal load sign on the front. It's Unitrans and Barloworld are running these fuel quads. Very safe, very efficient vehicles. I think they're proving themselves. And we haven't seen these PBS vehicles anywhere else in the world. The other countries that I told you about, this is pretty much a first. Yeah, I'll skip through that. Beefmaster for cattle. And then this is the SA Breweries. It's a 30-meter rig with 11 axles. This one also does about 50% less road wear. They're running on routes in KwaZulu-Natal and the Eastern Cape. And the Coca-Cola vehicle will look fairly similar to this one. In the first 3.5 months in Eastern Cape, with 5 of these vehicles, they saved over 100,000 kilometers. 28% less kilometers on the road, and the fuel savings in 3.5 months was 26,000 liters odd. And that's the ZZ2 one that's not operational yet. They're waiting for the upgrading of the Polokwane bypass, the N1 that they're busy upgrading before this one will start operating. And remember, as Jonathan spoke about primary distribution. So these PBS vehicles are appropriate for primary distribution. From the packing, in this case, it'll be from the pack house north of Polokwane to their distribution center near Lanseria. So this vehicle will travel on the N1 99% of the trip. From the distribution center, you use the standard vehicles to go to the markets and to the Pick n Pays and the Checkers and wherever they end up. I'll also skip the overtaking issue, but it's not really an issue. This is the Buscore biarticulated bus in Nelspruit. That's proved to be very safe on the routes that it's operating. Remember, so this vehicle will only operate on the routes that have been approved for it. So, and this is an overview of the savings of this pilot project. As I said, 150 million kilometers, 282 vehicles. So that we're saving about 86,000 trips a year, or it's a 22% reduction in trips, on average a 12% reduction in fuel savings. Now remember, this is over and above the savings that an RTMS operator would be able to get from better driver training, better vehicle maintenance. This is purely because of the increased payload. Greenhouse gas emissions, about 12% reduction. Road wear reduction is on average 13% less road wear. And the crashes is down by about 41%. So that's comparing baseline vehicles, which are all RTMS fleets, with the PBS vehicles. This is a new slide. We recently, so for every PBS project, we analyze a baseline vehicle. Remember I showed you that video clip showing the baseline vehicle, how unsafe it looked? So in all the projects that we've done up to now, the PBS vehicles, there's different levels. Level 1 is the most safe. That would be what we call general accessibility. So you can see the PBS vehicles obviously pass all the standards. But 56% of the baseline vehicles fail one or more of the PBS standards. So more than half the baseline or so-called legal vehicles that we've assessed in this project fail one of the performance standards. And if you look at the actual failures, the most common failures are the static rollover threshold, so that's rollover, rearward amplification, I showed you that road train, that rearward amplification, and then yaw damping, and that's how quickly the vehicle stabilizes after you've put a pulse in at the steering axle. So these baselines, over 35% of the baseline vehicles failed the static rollover test. And the pie chart on the left shows that 73% of the baseline vehicles failed one standard, 18% failed two of the standards, and 9% failed three of the standards. So it just shows the difference between the prescriptive approach and then the performance-based approach. That's the crash rates of the baseline and the PBS vehicles. As I said, the ratio of crashes for smart truck versus baseline is 1 to 1.68, which is actually a 41% reduction. And we've done, based on the RTMC report on cost of crashes in South Africa, we've done an estimate. That was when we had only done 136 million kilometers. We've probably saved over 200 million just in terms of cost of crashes in the pilot project. So that's it. I just wanted to give you an overview of this project. The pilot project will continue. The current issue is that Western Cape, Northwest Province and Northern Cape have got very few, if any, PBS vehicles. So the idea is to continue the pilot project until those provinces get fully on board, and then we'll have to make a decision, that ultimately the Minister of Transport, whether to incorporate this approach in the regulations. So thanks very much.